Hey there, and welcome to Into the Terminal, episode 112. I'm Eric, the IT guy Hendricks, and joining me is our usual host, Mr. Nate Laker.
Wait, where's Scott go?
You know what? That dude didn't even show up for work today, so I figured
I
I'd
know.
step in and lend you a hand.
All right, so we're gonna go completely off the rails today. No, just kidding. Anyway, so last week we talked about troubleshooting file systems. So this week we're gonna just talk about file systems in general, right? And then we'll probably get back to the troubleshooting track the next time we have Scott back, because he's better at whiteboarding than I am. Believe me, you guys don't want to see me whiteboard.
Yeah, we got a few questions, so we figured it made sense this week to take a pause from troubleshooting and talk about file systems and why should you choose one over the other. So, Nate, why don't we dive into the terminal, steal from Scott, and why don't you tell us what we're looking at?
That is the name of the show, isn't it? All right, so we're looking at a machine in my home lab here. What we're going to do is I'm just going to show you how to make a partition and put a file system in it, right? Because this is really common stuff that any administrator is going to eventually going to have to deal with, right? There's always this case where something isn't big enough, something needs to be added, whatever, right? So, first of all, we're going to go over some of the tools that we talked about in last week's episode. So, if you haven't checked out our troubleshooting episode, you're going to want to go check that out because we had a whole toolbox section where we talked about some of the tools we're going to touch on right now. So you might remember lsblk as my favorite tool for seeing what disks are attached to my system because it gives us this nice tree output, tells us what devices there are, what partitions they're currently on, and you're going to see that very suspicious empty disk VDB. You might guess that's where we're going to be working today. So just
It's very sus.
imagine.
It's very
Right. So
friendly.
just imagine, a ticket just came in and I've been asked to add a disk to this system, right? So I've already added a virtual disk to it. VDB tells me that it's a virtual disk, right? This is a virtual machine. If this was a physical disk that you'd physically plug the thing into, it would probably look like SDB, for example. But I digress. So first, I'm going to actually, let's just look, right? This shows us there's no partitions or there's no mounted file systems on there, but there's a tool called PartEd, partition editor, that I like to use for creating and viewing partition information on a disk. There's also Fdisk. We'll talk about that after the break. All right, so PartEd, you tell it what device you want to work with, dev VDB, and we're going to do print, which tells it, oh, not print. Well, I guess it uses abbreviations. Cool. I learned something today. I can be lazy and just, what if I just do like P? Does that work? Look at that. I can chop off all those extra letters. So this just tells us what's the current partition table on the disk. And I already knew it was empty. lsblk already told us it was empty. It's empty, right? But it also gives us information about things like how big is this disk? How many megabytes are available on this disk? And in this case, this just tells us, hey, look, it's 5 gig. This tells us a more precise number. Because when you're making partitions with PartEd, you actually specify them in how many meg they should be. So it tells us how many meg are available. So let's just clear the screen so it's easier to see. And we're going to, first of all, I didn't mention this, but you'll also see that there's no partition table, right? There's no label assigned to this machine, or not machine. There's no label. There's no disk label applied to this disk. So we're going to do a make label first, right? So we're going to do PartEd dev VDB because the first command is always the device you want to work on. And we're going to do mk label. And I'm going to use GPT. GPT, you have a couple options here. The most commons are MS-DOS and GPT. MS-DOS might sound like, oh, this is not a DOS machine, or not a Windows or Microsoft machine. Why would I use MS-DOS? And that's kind of the old disk label that you would have expected in older disks. GPT allows for larger partitions. On a 5 gig disk, it doesn't matter that much. There may be other nuances in performance-wise and whatnot, but just bear in mind, those are really the two most common options. So we're going to do a GPT. Sorry, I just hit the mic. And now if we do parted print again, it's going to tell us the partition table is GPT. And that's important information if you're working with a large disk because it'll kind of fill in what partition sizes you're allowed to do. I want to say MS-DOS supported up to 1 or 2 terabytes. And if you're working in extremely large file systems, GPT will let you use a much bigger partition size, right? So just keep that in mind if you're working with like SAN arrays and stuff, or disks that are larger than a couple terabytes. I remember running into this as a systems administrator when one of our, I think it was like a science division at the college, came to me and said, "Hey, we need to store a ridiculous amount of data. I need a 4 terabyte volume." And I'm like, I can't make one because I didn't, at the time, I didn't know GPT existed, right? So we ended up doing like this weird LVM thing where we joined them together. Then there were file system issues we ran into because of the size of file systems we could create at the time. So, but again, that's off topic for the moment. So we've got the disk label. Now we're going to make a partition. So Parted will give you prompts. I'm doing these in one-liners because I think it makes it simpler for someone who maybe wants to script this later. Parted is good for that. I think you can do that with Fdisk as well. Scott usually does stuff that way with Fdisk where he like does Fdisk and passes commands into it, but I think parted is just cleaner for this. So we're going to do parted again, dev vdb, and then we're going to do mkpart. Now, the next thing it asks for is the name of the disk. I'm just going to call it disk 1. You could call it whatever you want. Make it something that maybe helps you identify it later. I'm going to eventually put XFS on this, so I could have been like XFS disk or something like that. But at any rate, I typoed. There we go. I always do that. I don't know why. Deb instead of dev. They're so close to each other. All right. Where was I? And then we need to tell it the start and end of this partition. Now, remember, this is working in megabytes. I think you can probably tell it to work in other units, but by default, it's working in megabytes. So we're going to start at 1 because that's the beginning. Or is 0 the beginning? Maybe 0 is the beginning, but we're going to do 1. Then we're going to do 2500 because I want to make it about 2.5 gigabytes. Remember, 5 gigabyte disk. Okay, and then we hit enter, and it's just going to be like, yep, done. It doesn't actually even give us a confirmation. It just says you might have to put this in the Fstab for this to actually work. If I go back and do another print again using our newly discovered abbreviation for print, which is just P, you can see that now we've got a new partition in there called disk 1. No file system in it, no flags, anything like that. And it's about 2.5 gig, which is what I wanted. Now, like I said, I'm going to make a second one as well. I'm going to use the exact same command, except we're going to call it disk 2. And we're going to start at 2500 because that's where our last one ends. You can see right here, it says end 2500, right? And start at 1K or so. I guess that's about 1 megabyte or so. I guess we could have started at 0 maybe. I'll try that in some other lab when we're not live. We're going to start at 2500 and we're going to go to 5000 because as we know from the print earlier, we have 5,000 and a little extra available here. Now I could end at 5,369 and that would fill up the rest of the disk, but I'm just trying to make things simple here. So hit enter. If I do that print again, then ta-da, now we have 2 disks. Now, disks aren't that helpful unless there's file systems on them. So
what?
Let's do 1 or 2 more things here. First of all, remember lsblk from the beginning? Let's just show here. Now you see we've got VDB1 and VDB2. That's just another way to confirm, yes, the disk was added. It's added to the disk that we thought it was added to. Just another way to, sanity check and make sure everything is exactly where you want it to be. Because I'm going to tell you, there's nothing that's more anxiety inducing than doing disk changes on a production system, in my opinion. Right? Maybe there's other things like hardware changes or whatever. Oh, the CPU died. We have to replace it. That might be a little worse. But on a live system or a production system in a small maintenance window, there's no other case where I think you need to be extra careful than when you're making disk changes. So I always like to be extra sure. All right, so VDB1, as you might remember, is the one I said earlier we were going to put XFS on. If we do mkfs.xfs, there's other command line options you could use instead, like mkfs. There's like a command line option that'll tell it XFS, but these are like shortcuts to say XFS is the thing I want to make on this particular system or this particular disk. And we're just going to point it at dev VDB1. Now, this is going to use the defaults for XFS. you can absolutely define other options. And after the break, we're going to have a toolbox section like we did last time, and we'll show you some of the options that you could supply for mkfs, xfs to change the way the disk layout ends up, or the way the file system gets laid down. But at the very basics, here we go. We've got an XFS file system on here. Now, we have a second partition. Just for the sake of comparison, we're going to make an ext4 file system on that one. Same deal, right? mkfs.ext4 will make an ext4 file system. And we're going to go dev, I did it again, vdb2. Right? That's the second partition that we made on that disk. And now if we do lsblk again, you see this didn't really change much. But if we do that parted print again, see now it says file system XFS on disk 1 and ext4 on disk number 2. So, there's kind of some basics on how to make file systems. We're going to go a little bit more in depth on, the different tools at your disposal. Maybe we'll mount those file systems later, maybe compare disk sizes and whatnot. And we have a conversation toward the end about why you might use ext4 versus XFS in certain situations. So make sure you stick with us.
Yep. Make sure to. This is also your chance as we transition over to the deeper dive to like this episode. Make sure that you subscribe. That way you get notified every time we go live. And also, we have a Discord server. It's kind of quiet right now. I think people are on vacation right now, but we've had some good conversations and we've talked about laptops and battery life and that kind of thing. So definitely head on over to the RHEL Discord channel.
There's definitely an interest in the framework laptops in that group at the moment.
Yes, I'm biting. I'm just excited for when mine comes in, but that's
waiting.
A different topic for a different show.
Yeah.
All right, stay with us as we transition into our deeper dive.
All right.
Oh goodness! So Scott's out of the office this week, and we could have talked about anything we wanted to, but we did the good thing, and we talked about file systems. I'm kind of disappointed in us.
We could have gone completely off the reservation, and we didn't. But here we are talking about the exciting things that are file systems. But file systems are important, and disk layout is another thing we're going to talk about, or I should say, file system mounting layouts is something we're going to talk about. There's lots of reasons why you might make different choices when you're laying down file systems on your installations, and we're going to kind of cover some of those use cases. But
and before we do, I just want to say that you and Scott have been doing a fantastic job. I've kind of transitioned away from being a host of this show. My attention is focused more on producing, making sure that the graphics are there, making sure that the chat gets addressed, that kind of thing. But we had two very negative comments this week on the YouTube channel, and I felt like they were very undeserved. You and Scott work so hard week after week, and personal admittance, I came down with a summer cold just 2 days ago, and it's gotten worse today. So Nate very, very humbly stepped up and said, I can take care of the demos. You just run the stream and give me somebody to talk to. So Nate, Scott, I'm sure you'll watch this later. Thank you both for everything that you do on Into the Terminal. Really excited about the content that we've been making.
I'm better at the tech side than the hosting side anyway, but thank you, Eric. I appreciate that. Yeah. And we try our best to get everything right, but this is such a broad topic, and everyone has opinions about how things should be done and how maybe they think they would have done our examples and whatnot differently, or maybe we misspeak something from a technical perspective, and people love to call us out for those things. I didn't see the comments you're talking about, Eric, but I'd imagine they're in that vein because that's what they usually are.
Yeah. Usually people who make those comments have not tried to build a demo or have not tried to build a lab brand new from scratch every single week and then do it live on air when there's dozens of people watching you.
And these are probably people, or they could be people that have a ton of experience and have their set ways on how they do things. But that doesn't necessarily mean the way we're doing things is wrong. But
Like Rick said, you can ask 10 different sysadmins how to do something and you'll get 14 answers. I don't
That's
think the math
probably
lines
true.
up on that, but I'm sure if we ran the numbers, I'm sure it would be true. So anyway, I derailed us a little bit. Let's jump back on topic because I know if we go
Yep.
over 30 minutes, Scott will give us a hard time. So why don't
Yeah,
we
right.
talk?
If you're hosting the show and we still go over.
So
All right.
one of the sections that we had in the last few episodes has been kind of a toolbox section. So let's take the next few minutes and let's talk about what are some of the file system tools that I might need.
Yeah, sounds good to me. All right, so there's just like when we were troubleshooting file systems, just basically dealing with file systems, mounting file systems, creating partitions. There's a couple tools, and I listed a couple here. Again, there's probably a bunch that could be useful for other use cases, but we're going to go with some basics here to get people started. So, first of all, we used Parted in the beginning. Now we're going to talk about Fdisk. Fdisk is a fine tool. Especially because it's been around for so long and a lot of people are just so familiar with it. Also, in my old MS-DOS days, Fdisk was the exact same name for the tool you used to manage fixed disks, which is what Fdisk stands for. I'm sure there's lots of other colloquial names for Fdisk, but we're not going to go into those live on the air. So Fdisk, again, you can sort of script or pass commands in through Fdisk, but I always did it interactively, and I'm not sure if that's the way everyone does it or not, but that's how I'm going to do it. So if we go to dev, not deb, vdb, with Fdisk, you can see it gives us this interactive prompt. If I hit M, it'll give me the very short list of commands that I could be passing into Fdisk in order to get different management tasks done. So first of all, we're going to do a P for print. Same deal as with Parted. P will print out the existing partitions on the disk, and you can see these are the same partitions that we made earlier in the episode. But what we're going to do is, just for example's sake, remember I left some free space at the end of this disk. We're going to make a new partition with an N, and it's going to ask us what partition number do we want to use. Now, one of the things with MS-DOS partition tables versus GPT is, and that doesn't mean AI GPT. This is, what is it, global partition table GPT? I think that's what that stands for. But with an MS-DOS based partition table, you get partitions 1 through 4 are your quote unquote primary partitions. And then when you get to 4, if you create that as a partition and there's still space left on the disk, you can't make any more. So what you have to do is 1 through 3 can be primary partitions. And then number 4, you make an extended partition instead, and then you can make more partitions within it. GPT doesn't have that limitation. You can see here it says partition numbers, and I can go all the way up to 128, which is more than you'll probably ever need on a standard physical disk. If you've got 128 partitions on a standard physical disk, that seems pretty excessive.
Might be time to rethink how you built your application.
Yeah, right. So we're going to go with partition number 3, and we're going to go with the defaults here. One thing I do like about Fdisk is it'll just intelligently fill in the start and end of your partition based on the current size of your disk. Now, if you didn't want to fill the rest of the disk, you would have wanted to figure out, and I think this goes in blocks, sectors. It's in sectors, but you can also specify in kilobytes, megabytes, gigabytes, terabytes, or petabytes when you put in the size, right? So I could have said I want it to be 300 megabytes, and it would have made me a 300 megabyte disk, or partition, I should say. Okay, so that's done. If we hit W, that tells it to write the changes that we just made to the partition, and then it exits out of Fdisk. Now let's clear again, and if we do that, well, actually here, let's just look at it. Actually here, remember I was using parted print before? If I do fdisk-l and then dev vdb, it'll give me a similar output from Fdisk, right? So there we go. If I did that parted dev, I got it right that time and thought I got it wrong and then backspaced it. Print, and you can see right there. the partition table is related to the disk. Doesn't matter which utility you use to make it. Makes it in the same way, and you can get back to it either with Fdisk or with parted. All right, so now we have another disk. I talked earlier about mkfs and the ext4 and the xfs variants of that tool. If you do mkfs dot and then double tab, you can see there's a bunch of other ones in here for making different file system types. You can make FAT and ext2 and 3 and whatever cramfs is. I've never used cramfs. I've heard of it. I don't really know what it's for. Minix, VFAT, MS-DOS. VFAT, I think, is FAT32 versus FAT is FAT16.
Yep.
And these all have their own different, I don't know what MS-DOS is versus FAT or VFAT, but there we go. Maybe it's just an alias for one or the other. And these all have their own limitations and their own compatibility, right? So if I'm working on a system that maybe, I don't know, needs interoperability with a Windows system, I might use FAT or VFAT, right? There are extensions that'll use NTFS as well, but they're not supported out of the box, right? So that's why that's not in this list here. All right, so I mentioned earlier there's a bunch of different options you can pass into mkfs. We're going to look at ext4 -- help will give us a bunch of those options. Obviously, that's like, oh, look, there's a ton of options. What are they for? The man page is also super helpful. So you can see, you can get better descriptions as to what all these different options are. But I'm going to tell you, you can do stuff like specify the size of the inode table and how often the disk should be checked, I think is something that you can specify at the time when you create the partition or create the file system. There's a bunch of options. Block size, right? That's another thing. If you've got a specific use case for the disk that says smaller block sizes really work better for this particular application, then you have control over that. You can set the block size smaller. If you want to make it bigger, you make it bigger, that kind of thing. Cluster size, root directory. I don't know what the root directory is even for here. Copy the contents of the given directory into the root directory of this file system.
Oh, that's cool.
I didn't know
no
that
idea
existed.
You can do that.
Learn something new every day. So there you go.
And that's why I'm a podcast host.
Yeah. And of course, XFS has similar. Here, let's do the -- help first. So I think that one was a little bit easier to read. Yeah. So this one gives you a little bit more of a verbose output for the -- help on side of. Oh, apparently -- help isn't even an option. It just assumed that I needed help because I passed in an option that didn't exist. But at any rate, you can see here, there's a bunch of different options you can pass into XFS. Same deal, right? This is about tuning that file system as you're laying it down, setting sector sizes and what kind of output you want from the tool as it's running. All right, so we made file systems, but we didn't mount them. We did talk about mount in our troubleshooting file systems episode, but we're going to go ahead and use it here. Mount -t xfs, that tells it what type we want to, what type of file system we're mounting. It generally detects this automatically. For me, it just feels like the right thing to do to not make it detected, because I always worry that something's not going to get detected properly. My file system's going to get mounted wrong, and then things are going to go horribly wrong. Although that's never happened to me. I'm just paranoid like that. We're going to say what? Dev. I got the V and the B on that one. VDB1. And we're going to put it on /mount just because that's really handy. And you can see now there's nothing in there because we didn't put any files there. But if we did like a df-h, we can see it there now. If I did lsblk, I think will show me lsblk will show me that it's mounted now on /mount. See here, right? So all the tools that we're using that respect where the thing is mounted are now showing it that it's mounted there. And there's a bunch of different options to mount, which we're going to actually touch on as we talk about the next tool, which is lsblk. Sorry, which is Fstab, Etsy Fstab. If we look at, if we look at the man page for mount, and I happened to look this up earlier, if we go to line number 430, it gives us all the mount options. Did I get to the right? Huh. It's not the right line. Oh no, wait, it's the FS. Hold on. Man FS tab. Was it Man FS tab where I found this? Sorry, guys. No. All right, so apparently the line count that I found previously while looking this up is not where I want. I wanted to look at the mount options. So there were mount options for like general mount options, and then there were mount options for specific file systems. And I'm obviously I can't get to that now because for whatever reason my terminal is not. And I'm sorry for the dogs barking in the background if you guys can hear them. They're going crazy over something. Anyway, there are mount options within the mount tool, which then translate to when we're working with Etsy Fstab. Now, Etsy Fstab is where you tell the system how to mount volumes at boot time, right? Or how to almost like make shortcuts for mounting a volume, right? So if I go down in here, these are all defined by UUID, and that if we do the, what was the command again? BLKID, it'll tell you what the UUIDs are for our different partitions. So you can see VDA1. Let's see if the VDBs that we just made are in here. There we go. So here's the UUIDs for VDB 1, 2, and 3. So when you're mounting stuff in Etsy Fstab, you can use that UUID. And the reason you might want to use the UUID is because that is unique. It's in the name, right? Universal or unique universal ID, I think is what UUID stands for. Maybe it's the other way around. But it is a unique identifier. So if for some reason dev VDB becomes dev VDC, for example, or there's some underlying driver change or something that changes the block device path for that disk. This happens a lot with network attached or SAN attached disks. You reboot the machine and the all of the disks come back in a different order, and now VDB is VDC, right? And if you just said mount dev VDC1, that may change from boot to boot. It shouldn't, usually doesn't, but sometimes it does. Right. And the UUID is to account for that. Sometimes it does use case. But in this case, it's hard to remember and type a UUID, but it's easy to remember and type dev VDB1, right? So I'm going to use that for my example. Just keep in mind, and you can see the examples right here. If you do UUID equals, and then that UUID that you got from block ID, you can use that interchangeably with the direct path to where you're mounting. So okay, so we're going to say dev VDB1 should live on /mount, and then you tell it what file system type. That one was XFS, if you recall. And then this column is options. These are mount options. Now, last time we talked about read-only and read-write as the only options that we were touching on. There's a whole bunch of options that you can pass to different file systems based on what they are, what they do, and what partition type that they are, right? We're going to go with defaults, because that's what they're there for. But you could also say, oh, this is read only, or I don't know, I'm having trouble think. How about like is async one of them? I think makes it an asynchronous write mount. Anyway, you can comma separate and put a bunch of different options in here, right? Okay, and then the next two columns are based on, I think it's the order that they're mounted in, and then the time between file system checks, right? Yep. I think that's what those two columns are, if I'm remembering the right order. So you can see that the defaults here, everything's 0, 0, but you can change those based on your use cases. So we're going to stick with the 0 and 0. And now if I umount, well, let's clear the screen here. Now if I do mount /MNT, it'll read the FS tab. Oh, systemd still uses the old one. Right. I forgot to mention that. When you change Etsy Fstab, systemd is kind of aware of mounts. So if you do a systemctl daemon reload, then that'll refresh that awareness from systemd. But I think it should have still worked here. Yeah, it still did the mount for me. Just keep that in mind that if you want systemd to reflect the changes in Fstab, you have to do that daemon reload. But now you can see that it's mounted. And if I rebooted this system, it would mount that at boot, right? Now, the only reason it wouldn't would be if the disk wasn't available at boot. And that's one of the dangers of putting a device inside of Etsy Fstab is if it's like network attached, for example, and the network doesn't come up. If
Mhm.
it's SAN attached and your HBA or your fiber channel NIC or whatever doesn't come up, then you could have problems at boot time, which will actually halt the boot, right? And there's options you can put in there that call it a soft mount versus a hard mount that'll say you're allowed to skip this if you have to, right? And we touched on that a little bit in our last episode, and I think in our next episode we're going to go a little bit deeper on that. But just kind of keep aware that those exist. And that's essentially our toolbox. Any comments there, Eric?
Um, not in particular. I've used Fdisk and mkfs for a long time. Eventually, it just becomes kind of muscle memory. Most of the
Yeah.
time, when I'm building a system, I'm excited about next week's episode. I'll go ahead and tease it now. We're going to be talking about troubleshooting LVM. So, logical volume manager is usually how I manage a lot of my system disks. So there's the boot partition, and then everything else pretty much just gets handed over to LVM.
Yeah, that's how I usually do it too. In fact, you can see that right here in the way my disks are laid out.
Mhm. We might have to do an introduce. Actually, I think we have an introduction to LVM episode somewhere in our backlog. Um, but as far as mounting disks and creating raw partitions on top of them, that's not something I do much anymore.
Yeah, I agree. That was a practice I picked up probably more than a decade ago at this point. We had a bunch of RHEL 5 systems that were still using
Mm.
disks directly on, like using partitions directly on disks. And when we went to RHEL 6, we're like, all right, LVM brings so many more options for disk management that we started using LVM for everything. And I haven't looked back. It's been great.
Agreed. So I guess what we're saying is tune in next week to talk more about LVM. Um,
Yeah, absolutely.
So one of the questions we got last week was about EXT versus XFS. And so as we're wrapping up today's episode, I wanted to spend a couple of minutes and talk about the differences. And we've got a couple of resources where you can go and do some digging, but uh, between so the default in RHEL, was it 7 that we
I think
switched?
7 is when XFS started.
So EXT has been around forever. Um, EXT to 2, 3, and now we've got EXT4 as the latest.
Hmm.
But around RHEL 7, I'm pretty sure it was RHEL 7, we switched from EXT to XFS being the default. Uh, but they're both still around, and I think there's specific use cases for both. So digging through both our own knowledge base and doing some online research, came up with a couple of things, a couple of differences. Like when would you use one over the other? Um, One thing that I came across in my research, and maybe this was for you as well, um, was that ext4, while it doesn't have the file system size support that XFS does, it handles small files much better. So there are certain types of databases that would write just hundreds of these teeny tiny files, and there'd just literally be hundreds of them in folders with numerical IDs, and none of it was understandable from a human perspective. But
Hmm.
ext4 seems to index and read those files a little bit better.
And we talked a little bit about this related to space on our last episode about file system troubleshooting, where XFS has a little more overhead, so that if you have an extremely small disk, which doesn't happen that often anymore, but it's just something to keep in mind. If you're in a use case where you have a small disk, EXT will use less of that disk for file system metadata, whereas XFS may eat up a little bit more of it. So there's benefits to XFS, but if you're working on extremely small file systems, you may want to steer to something more like EXT.
That said, though, a lot of that metadata space that XFS uses, well, I mean, if you're adding a terabyte disk or multi-terabyte disks,
Right.
um, it
It
that
really
that
doesn't
metadata
matter.
is incredibly small.
Right.
but I think you get so much more benefit. XFS does a lot under the hood, behind the scenes, to help balance. It's I don't want to say better. It's got a different approach to writing caches from memory onto disk.
Hmm.
Although a lot of people on the internet, uh, they posted online, so it must be true. Said that XFS is a little bit less fault tolerant. So if your system loses power, it's not as good as ext4. But I think that's more experiential than fact.
Okay. Some of the docs I'd read on XFS is that it actually recovers better. It doesn't require the file system check that ext4 did. So I guess we're getting conflicting information online. So surprise.
That never ever happens. I'm going to write the producer and complain.
You should complain to the guy who curates all of the content on the internet that you found something that is wrong and make
Perfect.
sure he fix it.
I will do that. Um, so and the point we're trying to make is for the layman user, for the average workload, if you're running a database, if or not a database, if you're running, say, just a super businessy website, something along those lines, you're good either way. And as for me, I've always had the mentality of the more you change things from vanilla, the more difficult it's going to become to manage, especially to troubleshoot those issues. So when you're looking at just deploying a standard workload on top of a standard RHEL 9 box, the defaults are defaults for a reason. And for the most part,
Yeah.
when you're talking about file system operations, you're probably fine taking the defaults.
Yeah. Now there's certain edge cases, obviously performance and whatnot. If you dig into performance and decide that one file system is better than another, then great. You've done your legwork. You understand that's a better file system for what you're doing. But sometimes you need to take into consideration what's been done in the past, right? If you're working on an existing system, say it's a RHEL 8 box, the previous admin chose ext4 for whatever reason, and you're just adding a new disk to it or whatever. Um, it doesn't make it's not going to necessarily hurt anything to make the new disk XFS, for example. But if the rest of the system is already ext4, sometimes it's easier and makes it easier to manage in the future if the disk you are adding follows the same standard that the previous admin used. Now, there's really no, I'm not going to, there's no technical backing to that I'm going to throw at you. It's just from experience, right? I can tell you that when it's 2 a.m. and the pager went off and you're still bleary eyed, the least inconsistencies as possible on a system is going to be better, right? So if you're on a system, it's RHEL 8, RHEL 9, whatever, and for whatever reason it's all ext4, just use ext4 because you're going to thank yourself later. But if you're building a new system and there's no other reason not to, I would just stick with the defaults and use XFS.
I agree. I like it. We have solved the world's problems today on Into the Terminal.
Absolutely. I mean, maybe not the world's problems, but because there are many.
A few. All right. So we've hinted at this already. So next week, no, 2 weeks, because I think
I don't know.
pretty
We
much.
got to work out scheduling because there's travel coming up. There's a holiday coming up. There may be missed weeks.
So we've gone ahead and canceled next week's episode. It's a holiday here in the United States, and I think half our team took the 5th off. Um, so we're a little short staffed next week. So there won't be
I
an
didn't. I
episode
could
next week.
theoretically do the episode all by myself, but that would be a disaster. I guarantee.
I'll let host Scott know that you volunteered.
Yeah.
But with 111 episodes in our backlog, I imagine there's probably one you've missed. So why don't you go back,
Yeah.
check out one of our old episodes? If
There
you
you go.
missed last week's episode, and here's your takeaway before we give you 100 things to do. If you have one action that you take in the next week, go back and watch last week's episode. It was great. Nate and Scott talked about troubleshooting file system issues, which was what kind of spawned today's topic. So we kind of we pulled a Star Wars and we did the
We made a
middle
prequel.
and then we made a prequel today. So uh, so if you take nothing else away from today's episode, go watch the troubleshooting episode. It was great. Scott and Nate did an awesome job, and I was off hiding in the background producing the episode. So, um, let's see. So coming up at a date to be determined, and this is why you need to subscribe and hit that bell. We'll be talking about troubleshooting LVM on Into the Terminal. And then, much like myself, our guest on RHEL Presents, Jonathan from Yubico, came down sick earlier this week. So we ended up postponing the Yubico passwordless authentication on RHEL Presents episode. And then Nate decided he was going to travel here in a couple of weeks. So I believe that episode will get rescheduled for the end of July, which means that our next topic is Podman Desktop with AI Lab. So if you've been wanting to dive into the world of AI and figure out what LLMs are and what RAGs and all these other things mean, you can do that with Podman Desktop, and tune in a couple of weeks for RHEL Presents, where most likely that's what we'll be talking about. Hopefully our Podman Desktop team isn't on vacation as well. Nate, any closing thoughts before I stop talking?
I had all my labs ready for that episode too, and it was just like last minute. Poor Jonathan wasn't feeling well, which I get, I understand, but yeah. And people are excited about that. If you're not familiar, it's passkey support with IDM for RHEL, which is a pretty cool feature. We've got some video content already out there on that, but we were going to talk to Yubico about kind of the what's and whys and stuff. So tune in. Make sure you subscribe so you can tune in for that later when it happens. And that's all I had. I mean, like, happy Friday, folks.
All right. So thank you all for joining us. Thank you all for sticking around through 41 minutes. We're going to hear about that. 42 minutes of fun, and definitely join our Discord server. It's up there.
Yeah,
you can scan the QR code, or it'll be in the show notes within about half an hour of the show wrapping up. So thank you all for joining us. Scott will be back with us here in a couple of weeks, and Nate, thank you for taking the reins on this, as I'm just
absolutely
out of it. So I'm going to go take a nap. Until then, thank you all for hanging out. And on behalf of Nate, Scott, myself, and the entire Red Hat Enterprise Linux team, thank you all for joining us, and happy Into the Terminaling.
Have a great one.